Hello everyone, this is K.Sangeetha, Assistant Professor, EC Department, SNS College of Engineering. So in the last video, we have seen the basics of image processing and the fundamental steps involved in the digital image processing and the main components of digital image processing. So this video covers how the image is converted as digital image. So there are two processes involved. So in digital process, image processing, signal captured from the physical world need to be translated into digital form by digitization process. So in order to become suitable for digital processing, an image function must be digitized both spatially and in amplitude. This digitization process involves two main processes called sampling and quantization. Sampling, that is digitizing the coordinates value, is called sampling, and quantization is digitizing the amplitude value, is called quantization. So the analog image is continuous, not just in its coordinates, that is x-axis, but also in its y-axis. So the part that deals with the digitizing of coordinates is known as sampling. So in digitizing, sampling is done on independent variables. In case of y is equal to sine of x, it is done on x variable. So when looking at this image, we can see there are some relation variation in the signal caused by noise. In sampling, we reduce the noise by taking samples. It is obvious that more samples we take, the quality of the image would be more better, the noise would be more removed, and same happens vice versa. However, if you take sampling on the x-axis, the signal is not converted into digital format unless you take sampling on the y-axis too, which is known as quantization. So sampling has a relationship with the image pixels. The total number of pixels in the image can be calculated as pixels is equal to number of rows into number of columns. For example, let us say we have a total of 36 pixels in this, that means we have a square image 6 into 6. Thus we know in sampling that more samples eventually result in more pixels. So it means that our the continuous signal, we have taken 36 samples on x-axis. That refers to 36 pixels of this image. Also, the number sample is directly equal to the number of sample is directly equal to the number of sensors on CCD array. So the next one is quantization. Quantization is opposite to sampling because it is done on y-axis while sampling is done on x-axis. Quantization is a process of transforming a real valued sample value to a finite number of distinct values. Under quantization process, the amplitude values of the image are digitized. So there is a relationship between high enough for human perception of the fine shading details in an image. So the occurrence of the false contours is the main problem in the image which has been quantized with insufficient brightness levels. So here below as the example for image quantization process. So these are the examples. So after converting the digital image, it has been represented as represented in matrix form. So in this video we seen that what is sampling, what is quantization, so how the sampling is taken, how the quantization is taken, and how it is converted as digital image processing So suppose when we want to improve the quality of image, we can increase the levels of assigned to the sampled image. So if we increase this level to 56, it means we have a grayscale image. So the number of quantization levels should be high enough for human perceptions of fine shading details in the image. So which has been quantized with insufficient brightness level. So these are the main topic covered in this video. So this video will help you to understand what is to understand the sampling and quantization. Thank you.